International Schools and our online lessons. Today is the 22nd day of June in the year 2020. I'll be introducing you today to subject Basic Science, and the topic here is forces. We are continuing this topic because we had some objectives to finish explaining. So this class is for JSS1 and JSS3 students. Yes, you had me right. JSS1 and 3 students. So last time we did explain so much about forces, and if you remember, we did define force to be anything that can help a body in moving or stopping, anything that can help a body to move, or anything that can also help a body to stop from moving. Okay? And we also explained or went further to state the types of forces, where we said we have the contact and non-contact types of forces. So under the contact force or contact types of forces, we did mention the push and the pull, the drag, kick, etc. And under the non-contact types of forces, we did mention gravitation. We also mentioned electrical. We also mentioned magnetic forces or magnetic force as a non-contact type of force. But now I believe you should understand what we mean by contact and non-contact. Contact means when something has a physical touch with it, and non-contact means when it does not have a physical touch. You know, like when we're talking about non-contact forces like gravitation, the law of gravitational force states that everything around the earth must do what would be dragged or fall within the center of the earth. So the force or the gravitational force helps it to come down, it drags it, it pulls it down without making contact with it. That's what we mean by non-contact forces. And when we're talking about contact forces, you know, when you want to push the door in your house, when you want to open the door in your house, what do? You open the handle and push. And in other times, or most times, you open the handle and pull. That's an example of a contact force. So for today, we'll be looking at balanced and unbalanced forces. Balanced and unbalanced forces. Now, these two forces act in pair and occur together. In pair simply means that most times we must have a balanced and unbalanced force for it to work together. Okay, so let us first look at what a balanced force is and what an unbalanced force is as well. A balanced force, this is defined as the two equal and opposite forces acting on a body that is equal in size and opposite in direction. Take it again. Two equal and opposite forces acting on a body that is equal in size and opposite in direction. Equal in size and opposite in what? Direction. Now, this type of force does not cause any change in motion or direction of an object. It is a force that acts on a body when at rest. Just like one force we call the static friction or the static force. So this type of force, or less known as balanced force, acts when the body is at rest. It is the type of force that that does not cause any changes in motion. So this balanced force does not cause any change in motion. So if this balanced force is applied in a body, it does not cause that body or that object to change in its motion or direction. It does not make it to move. That's what this means. Remember, we talked about forces. We defined forces to be what? A body or anything that can help a body to move or change direction or stop. So this kind of force that we call balanced force does not require the body to move, does not require the body to be in motion. That is a balanced force. Now, an unbalanced force, this could also be defined as two unequal but opposite forces acting on the body. Two unequal but opposite forces acting on a body. This is the type of force or forces that causes change in motion of an object or a body. It is also a force which in a body experiences when in motion. Example, a seesaw. Okay, now this type of force is experienced when a body is in motion. It is experienced when a body is in motion. Let's take it again. That it's defined as two unequal but opposite forces acting on a body. This is the type of force or forces that causes changes in motion or direction. That is, this is to say that this type of force or an unbalanced force causes a change in motion or direction in a body or in an object. It is also a force which a body experiences when in motion. This can also be known as friction. That's why we're going down to friction now. When in motion, example, a seesaw. Now this takes us to this part. This is what you really need to understand for you to understand this one better. Friction. What's a friction? Friction is a force that opposes motion when two surfaces are in contact with each other. It occurs when a solid object moves on another solid object. Now let me tell you this. Most times you see that your vehicles, let's use a vehicle to be this body this time around. So vehicles. Okay, so do you want me to use the term car or motor? I know some of you now would not want to hear the term motor. You say, no, we don't have a motor in my compound, we have a car. Okay, fair enough. So let's use your car for example. So what helps the car to move? Some of you will say the tires. But what helps the tires to move? What happens? Now, what is it called? The spinning of the tires, or the motion between, or the movement between the tire and the surface or the carotide or the ground where the car is placed. What is it called? It's called friction. Why is it so? Because it is what is one surface rubbing with another surface that enables it to move or stop. So that can also be termed an unbalanced force because it causes the body of the body to change in direction or in motion. Now look at this. Friction is a force that opposes motion when two surfaces are in contact with each other. It occurs when a solid object moves on another solid object. Let's take a look at this. Or when a solid object moves in a liquid or gas. The rougher the surface, the greater the frictional force between it and any other object placed on it. Now, we said the rougher the surface, the greater the frictional force. Now, take a look at this. Put your two hands together. When you put your two palms together like this and rub, just begin to rub them. This can be termed as friction, right? Yes. What happens then thereafter? Okay, how about if you also have something like a piece of paper between your two hands? When I want to look at the greater the frictional force between it, okay, where is it? The rougher the surface, the greater the frictional force. So I want to experience the frictional force now. Or when you have your grater, good example. When you have your grater, the one you use in grinding your coconut or your water yam, what happens? The rougher the surface, what happens? The greater the frictional force. Hope you understand this. Okay. For example, when a baseball, let's take an example that will make you understand it now. For example, when a baseball player slides in another player, the joint of his or her legs rubbing on the dirt provides enough force to stop the slide. Okay, Now, you may not really watch baseball or players or basketball. Let us take an example with football, the one you see everywhere around you. Okay, when you see football players, when they play football, at times when they score goal, they slide to celebrate. When you want to celebrate, at times you see that they slide, you know. So now I want to look at friction there. They slide. So as they slide, even whether with their nails or with their legs, what happens? What happens? The surface, the rougher the surface, it helps in stopping the player from sliding. And that is where we say that friction is the force that opposes motion. It opposes motion when two surfaces are in contact with each other. Okay, let's look at types of frictions. The types of frictions that we have two main types of friction. We have the static friction and the dynamic friction. Dynamic here is just like saying the one that moves. That's what it has to do with kinetic energy or sliding. While static here, just like the word here implies, static, something that's not moving, something that's in one place. So, static friction. This type of friction occurs when a body moves against another, but in a fixed position. I'll take that again. Static friction is the type of friction that occurs when a body moves against another, but in a fixed position. That's you have to say that what that particular object has what is static friction. Okay, dynamic friction here. This type of friction occurs when a body moves constantly over another body. When a body moves constantly over another body. Take for instance, when your vehicle is driving, it's a body, right? Moving over another body, that is the surface. Okay, and it enables the brake, you know. Friction also helps when you apply your brake. When you're driving your car and you apply brake, when you press your brake system, it helps the car or the body to stop or to decelerate and stop from the motion or movement. Okay, let us now look at the characteristics of friction. What you must see or what you see to know that this particular object or thing possesses this friction. Now, friction opposes motion. That's number one. Number two, static friction or static frictional force is independent of the surface area in contact. Why is it independent? Because it is static. The static frictional force is independent of the surface area in contact because it is static. The frictional force is always equal to the forces or to the force applied through weight. The frictional force is always equal to the force applied through weight. Okay, let's take the next one. So the fourth characteristic of friction is that the ratio of frictional force and the normal reaction is constant. That is, force all over the reaction is equal to what? The coefficients of friction. See it here, where R stands for what? Reaction, F stands for force, and U stands for coefficients of friction. Now let us look at the uses and advantages of friction. Of course, you know, anything that has advantage must also have a disadvantage. So in due course, we're also going to consider the disadvantages of what? Friction. But then let us look at the uses and advantages of friction. Number one, frictional forces helps in the grinding of pepper. I know you're going to shout and other things. Yes. So frictional force helps in the grinding of pepper and other things. In your home, I'm sure most of you, especially the girl children, my students, you do pound pepper. For every time mom is cooking in the kitchen, you want to help her to pound pepper, tomatoes. For those of you, you know, who do eat afang soup, you also pound what? The afang leaf. So what helps you in grinding it? What helps you in grinding those substances you put in the mortar? It is the friction. So one of the uses, as we stated, is what? that the frictional force helps in the grinding of your pepper, tomatoes, etc. Name them. It enables us to sit without stumbling when the brakes of the car is applied. Now, if not for frictional force that helps you to be balanced, you know we have balance and unbalanced friction. So, if not for the balanced one, or for the balanced forces that enables you to sit without motion or without changing your direction or motion, when the brakes of a car is applied, what happens? Some of you will tumble. But when this brakes is applied, though it depends on how it is applied, it solely depends on how the brakes of the car is applied. When it's applied in a very abnormal way, of course, abnormalities will take place. So you will have to tumble or move from your vehicle or move from where you're sitting. But when it's applied in a moderate way or in a normal way, frictional force does what? It helps you not to tumble when the brakes of the car is applied. Number 3 is that it enables a nail to stay tightly in a hole between two pieces of wood. So now you have a wood. As a furniture designer, you put your nail inside. It is frictional force that enables that nail to stay in there tightly without it being loose, to fall out. So we also have here, it helps us to walk, to run, drive, etc. without slipping. Of course, with frictional force, you have your balance. You walk without slipping or to fall, except if you walk in a very shiny or smooth surface that has been dense with maybe water or substances or lubricants that could make you to slide and fall. But on a normal ground, you can walk without falling because of what? The advantages of friction. So we also have here that it enables us to sharpen our knives and cutting tools with grinding stones. So now, just like what we did before with grinding stones or file, just like what we did before when we did this way, that's friction. So when you hold your knife, your kitchen knife or your machete or your cutlass, the one you want to use for farm, and you choose to use a file to sharpen it, what happens? Okay, this is the knife and this is the file. As you sharpen, what happens? Friction helps you to do what? To sharpen. It grinds the metallic surface of that knife that will not make it what? To be sharp. Or when you want to use a sharpened stone, like in the village, most of our grandmothers or grandparents or our brothers and sisters in the village do. You see, they sharpen the knife with the stone. What happens? What makes it too sharp? What helps the knife to get sharp? That is the friction between what? The two objects, between the knife and the stone. Okay? It enables us to design and construct motorcycle brakes, clutches, etc. Of course. So let us now look at the disadvantages of friction. It reduces the efficiency or productivity of a machine since it uses upward energy. It causes wear and tear of what? This is wear and tear of motor tires and machines. Now, why do your parents, now I'm referring to you, my student, because I know none of my students has a car. So why do your parents or uncles and aunties buy tires often, maybe after 6 months or after 1 year, after 2 years, depending on the way it has been used? Why do you have to buy tires again, motor tires or motorcycle tires? Why? Because of this disadvantage. Friction here will make the tire to do what? To tear. It will either tear or it will wear out. You know when something is faded? When something is faded, it can also be seen as something that is what? Wear. That's what we have here. It causes wear. That the tire will now fade away. Because as you keep on having this friction between the tire and the rough ground, even the smooth ground, what happens? As the tire keeps on spinning, it engages in what? Friction, which can also be converted into heat, because when you do so, you also feel the heat Okay, so when there is heat, what happens? It burns down, it reduces the energy, right? So it causes friction here, causes wear and tear of motorcycles, motorcycle tire or motor tire or your car tires and machines. It slows down the movement of cars. Of course, that's why at times you see that the plane is faster than your vehicles, because friction between the tires and the ground, the rough ground, slows down the movement of cars. But when you're in the free fall or the air, flying like a plane, it's not that slow. Okay, now let us look at ways of reducing friction. The use of ball or roller bearings. The use of ball or roller bearings on a wheel where a wheel is turning. So there should be a ball or a roller bearing where there is a wheel turning. We should also have say the use of oil to lubricate the joints of moving parts of a machine. Not just moving machine, not just the parts of a moving machine or not just the parts of machines. We also have other things that due to friction can also be worn out or spoiled. You have your doors, the door in your house. Most times, or if you observe, when it came newly, it doesn't make noise. When you want to open the door or close it, it doesn't make noise, right? Yes. But with time, due to maybe the weight or one thing or the other, one factor or the other, the door begins to make noise. Check it properly. You too can fix it. Just check it properly or check it closely. You would observe that perhaps a particular part of that door is rubbing with another part. Maybe the part that should have been free is now rubbing with another part. So when it continues to rub like that, that is friction. So it brings out, it produces that noise. It produces the noise you hear. And if you now allow it that way, it will destroy that door for you. Or it will cause the door to also do what? To wear or tear. So this is assignment for me. Write short notes on magnetic forces or pole. Write short notes on magnetic force or magnetic poles. State the law of magnetism. Now, if you're studying this law here, you'll see you have to do something like this for me. Use this to explain the law, where you have here you have this like this, and you also something like this too. It's repeated down here, where it's something like poles repels and unlike poles does what attract. It's one beautiful thing about magnets and the law of magnetism, that you have your magnet here. It's fine, right? But when you now break it, what happens? It's difficult to put it back together. Why is this so? It's because like poles repels. Like poles repels, and unlike poles does what they attract. When you break your magnet, you realize that like poles repels and unlike poles they do what they attract. So that's what we have here. Like poles like this repels, while so you see, like poles repels, unlike poles here, they do what? They attract to each other. So you're also going to explain what I call the magnetic field for me. What is the magnetic field? You're also going to explain this for me. If you need me to throw more light on that. Magnetic field here has to do with the magnet, the effect, the place or the area where the effect of this where the magnetic effect is felt, or where the magnetic force is felt. Magnetic field has to do with what? The area or the surface or the space between which the magnetic force is felt. Like when this light pulse repels, that is when it repels. What happens? The space, that's what this magnetic field refers to. But I need to throw more light on this, please. throw light on this. In our next class, I'll get the magnet, but if you can get one for yourself, fair enough. So in our next class, as I'm going to explain this, using your own assignment, using what you're going to write, we're also going to explain this. We'll carry out the practicals, we'll see how, we'll explain the law of magnesium, and we'll also see how light poles repels and how unlike poles attract to each other. Please continue to stay safe and carry out every other instructions you have to that will help you to stay safe. Because as you stay safe, you're also helping your neighbors, me as well too, to stay alive for each other. Thank you and see you in our next class.